Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 27th video in the Introductory Programming in Java full course, and the second video of Lesson 5, Static Methods in Java. In the last video, we looked generally at static methods in Java. We'll spend the next few videos taking a closer look at different aspects of Java methods. Today, we're going to take a deep dive into parameters. Let's get right into it. Here is the simple quiz method.java program from the last video, which you may remember poses a question to the user and obtains an answer until the user gives an answer of A, B, C, or D. The question and possible answers are passed in as parameters to a pose question method, along with the scanner object. You may have noticed that the first 5 parameters are strings. When we're declaring string variables, we can write string and then our list of variables separated by commas. Can we do that with parameter declarations? No, we can't. We must give a data type followed by a parameter name for each parameter variable. Let's talk about the parameter names as well. The rules for parameter names are the same rules that we have for variable names and method names. They may contain letters, numbers, the underscore, and the $sign. They cannot begin with a number or be a Java reserved word, and by convention, they should be camel case and meaningful. Something I neglected to do when writing this method was document it. You may remember that we should include a java.doc comment at the top of our programs. And you may further remember that a java.doc is a multi-line comment that begins with /** and ends // and is in-program documentation that can be extracted by the java.doc tool to produce external documentation. If we use java.doc tags such as @author in our java.docs, the comments associated with the tags are extracted in a meaningful way. I'll add a java.doc at the top of the class with a description of the program, the author tag, and my name. And notice if I click on the java.doc tab in the view with the console, you can see the java.doc that is generated, which includes the description and has pulled out the author. Java.doc tags, which are specific words following the @sign, @author is one example, represent elements of a program that should always be documented. So there are designated tags for those parts so they can be extracted in a meaningful and consistent way into the java.doc. It is convention to include a java.doc comment over every method header. Eclipse will give us a little bit of help writing a method java.doc if we've already written the method header. If I type /** over my pose question method header and then press enter, Eclipse begins to fill in the java.doc for me with @param tags for each of the parameters and an @return tag because this method returns a value. To properly document our method, we should write a description of the method and then include a description to the right of each parameter and a description of what the method returns. Java.doc can be quite detailed, including HTML and links, but what I will write in this video will be an introductory version. The first line of the java.doc comment should be a summary description of the method. If there's more to say about the method, continue on, but make sure the first line can stand alone. Write the comment in third person. I'm going to write poses a question to the user and obtains a valid answer. Then there should be a blank line, and then a description of each parameter variable. I'll write the question being posed next to @param question, and then the answer designated answer A, the answer designated answer B, etc. for the other parameters. And finally, a scanner initialized to the input stream system in. For the return, I'll write the user's answer A, B, C, or D. Notice that we put each description in a column formatted by tabs after the parameter name or the return tag. And notice how the java.doc appears in the java.doc tab. Okay, now that this is tidy, let's go over a few qualities of method parameters that we may not have discussed in the last video, starting with the words that we use to refer to parameters. You'll probably hear people use the words parameter and argument interchangeably, and that's okay. But technically, what we have between parentheses in the method header, where we have string question, string answer A, etc., are called formal parameters. I have also heard them called dummy parameters, although I will not be calling them that. And they are also called parameter variables. I might call them that to emphasize that they are variables and, in fact, local variables to the method. Now below, where we're calling the method, the values we pass in are called actual parameters or arguments. I will call them both of those things. Usually I will say arguments. Notice that the formal parameters are always type followed by parameter name. The actual parameters, or arguments, are just an expression that will evaluate to the same type as the matching formal parameter, or can be implicitly coerced to that type. So, for example, we have string question as the first formal parameter, and we have a literal string. Remember, the simplest form of an expression is a literal as the first actual parameter. You don't specify the data type when you're passing the parameter in. So again, the actual parameters are expressions that evaluate to the formal parameter type, or can be implicitly coerced to the formal parameter type. For example, an integer can be implicitly coerced to a double. So we could pass an integer to a double parameter. And remember the definition of an expression. An expression is a construct made up of literals, variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. In our method call to pose question, we have 5 literals, all string literals, and 1 variable. We could pass in more complicated expressions. To illustrate, I'll concatenate the letter A and the closed parentheses with the first answer here. So A plus 400 less than or equal to CO2 reading, or CO2 reading less than or equal to 800. So that's a concatenation, a slightly more complicated expression than just a literal. When Java reaches the method call during program execution, it will first evaluate all of the actual parameter expressions. The literals, remember, evaluate to exactly themselves. The concatenation will take place. The 2 strings will be concatenated together, and the result is what will be passed as the parameter. And the variable, standard in, will evaluate to the scanner object that standard in is referencing. Once all of the actual parameters are evaluated, Java has an ordered list of values it's going to try to store in the formal parameter variables. It will make sure the types match, because this is essentially a bunch of assignment statements. We're basically saying question, the first formal parameter in the method definition, equals or is assigned the value of, and then our first actual parameter value. What is the complement of 400 less than or equal to CO2 reading and CO2 reading less than or equal to 800? And then on to the next. Answer A equals A 400 less than or equal to CO2 reading or CO2 reading less than or equal to 800. The value we got after performing the concatenation, etc. This type of parameter passing is called pass by value. It means the values of the actual parameters are copied to the formal parameter variables. They are separate variables. You can change the formal parameters within the method body, and it will have no impact on the expressions passed in. Now, if I get the actual parameters out of order, that will probably result in one of 2 kinds of bug. I'll have either a syntax error or a semantic error. A syntax error will result if the variables are out of order and the types now don't match. Let me move the scanner to be the first in the actual parameter list. And now I have the red X. Let's mouse over. It says, the method pose question string scanner in the type simple quiz method is not applicable for the arguments scanner string. Sometimes beginner programmers think Java will match the variables by name, so If I have a variable called standard in the actual parameter list, that should be matched to the formal parameter named standard in. That's not unreasonable, it's just not how it works. Java matches by order. It's up to you to pass the correct value in the correct location. Remember, what you're passing in doesn't have to be a variable at all. Variables are just one kind of expression. Most of our parameters are literals, with no variable names to match. So let's put that back and look at the semantic error. Suppose I swap the order of the first two formal parameters. Now I'm passing A, 400 less than or equal to CO2 reading, or CO2 reading less than or equal to 800, followed by what is the complement of 400 less than or equal to CO2 reading and CO2 reading less than or equal to 800, and then the rest of the parameters in the same order as before. Notice there's no red X because I'm passing in the correct data type for each parameter. But when I run the program, answer A is posed as the question, and the question is where answer A should be. And this happens because the first actual parameter value is copied into the first formal parameter. It doesn't matter what they might have been named if they were variables, or what they contained. If the data type is correct, Java will copy the value in. So this is a little harder to debug because it might result in an incorrect calculation if your values were numeric. That might propagate through a system. We'll talk about that in more detail in the testing video later in this lesson. Now, there is one thing you need to understand about parameters being passed by value, and that's what pass by value means for primitive parameters versus object parameters. And we'll revisit this topic in the next lesson when we're defining our own object types called classes. I have here a representation of memory. This is a little bit of a simplification, but I am showing you the relevant information. There are two kinds of memory, stack memory and heap memory. If you look at a method, like our main method, and find all of the variable declarations, then you know exactly how much stack memory the main method needs. For example, we see char answer, and we know a char needs 2 bytes, or 16 bits, so we know we need to allocate 16 bits for answer, etc. for each variable. And so stack memory can be determined before the program ever runs, just by looking at the code, which is what Java does. The literals, by the way, are stored in a separate location for efficiency. They are not stored on the stack. So here on the left is the stack. Now for objects, like the scanner, and any string variables, like the parameter variables in post question, Java allocates in the stack enough space for a memory address. In Java, that's 32 or 64 bits, depending on the Java virtual machine. That memory address is a location in the other kind of memory, the heap. The heap is for dynamically allocated memory. Objects are allocated in the heap for a number of reasons that are beyond the scope of this discussion. But for one, you can see by opening up an object, like the scanner in the debugger, that they can be quite complicated and can be composed of many other complicated objects. When code with the new keyword executes, like standard in equals new scanner system in, space is allocated for the object on the heap, and the memory address of that space on the heap is written into the storage location for that variable on the stack. When variables are passed by value, the contents of their location on the stack is passed to the stack variables for the method. So when pose question is invoked, space is allocated for it on the stack, meaning space for all of its variables, and the values from the actual parameters are copied in. That means for all objects, heap memory addresses are copied in. So you can see this is a whole new set of variables in pose question, a whole new set of memory locations. But the object variables are references to the same objects in the heap that main has. This is sometimes represented as arrows or pointers to the heap, which clearly shows that although pose question has its own copy of the pointer, it's still pointing to the same location in the heap. This is important if you have an object type that might be changed in the method. Strings are immutable, meaning they cannot be changed. But the scanner isn't immutable. If the method reads using the scanner, it has moved the scanner along to the next token or line in the input stream. Or if the method closes the scanner, then the scanner's resources are released, and the scanner can't be used again to read from that resource. We'll talk about the impact of passing objects as parameters again when we learn about objects and classes in the next lesson. Let's look at one more example of parameter passing to illustrate one more property of parameters. This program is called distancecalculator.java. You can see there are two methods, both called calculateDistance. How is this possible? The signatures of the methods are different. One takes 4 double parameters, and the other takes 6 double parameters. The first method will calculate the distance between the 2 points passed as x, y coordinates using the distance formula. The second method will calculate the distance between the 2 points passed as x, y, z coordinates using the distance formula. This is called method overloading. For some problems, you want to have more than one version of a method. For example, you might want a method that can operate on parameters of type string, int, or double. So you write 3 different versions, all with the same name, but that take the 3 different types of parameters. Or you might have a method that can operate with default values, but that can also be specialized. In that case, you write the method that takes no parameters or fewer parameters, so it operates with default values. And you also write the method that takes parameters to specialize it. As an example, we could write additional versions of the calculateDistance method that assumes one point is the origin, requiring only 2 parameters for the 2-dimensional version and 3 parameters for the 3-dimensional version. The other point by default would be 0, 0, or 0, 0, 0. This is an important feature of Java for designing solutions with methods. The requirement is that the parameter lists must be different in number, type, or both for each method with the same name. Java will execute the correct method based on the actual parameters or arguments being passed in. So in this example, with the method call on line 39, because there are 4 parameters, which are integers, but remember, integers can be implicitly coerced to doubles, then the first calculateDistance with the 4 double parameters is executed. In the second call on line 43, with 6 numeric parameters, the second calculateDistance, the one on line 33, is called with the 6 double parameters. Okay, I know that's a lot. These ideas will be reinforced as we continue our deep dives into method concepts, so hopefully by the end of the lesson, this will all make sense. As usual, I have included an auto-graded exercise in the description of this video, so you can practice with the idea of overloading. And the programs have been uploaded to my GitHub repository with a link in the description. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.